Now let us inspect this code, this code a bit more. So when you create the thread, you basically pass to that thread what function that thread is going to run. But when you look at this, you basically set up a few registers, a few pointers here and there. But this is something that we should talk a bit more about. So you basically set an instruction pointer to stop. And what you're doing is that you're not really calling the function that you're passing to the thread directly, but rather making a stop that basically calls the function from the stop. And stop function, I mean, you know what a stop function is. It's a dummy function basically, but in this case it's a dummy function that basically calls function. So you do not call the function directly, but you rather have the instruction pointer not pointing towards the function, but pointing towards the stop, because that function you can point basically that instruction. You could have pointed the instruction pointer to function instead. And that you set the arguments that basically to stop. I mean, this is basically now your register. So you set the arguments to stop to be a function, telling the stop function that the stop function will to call func, and you set the arguments to arg basically. And that what does this do is that it basically goes in here and calls function, and calls function with exactly the same arguments that you're passing to the thread. Okay, then why do you have this extra level of indirection? It seems quite counter-intuitive, but the reason is that you might implement a function, you might pass a function to a thread that does not call thread exit. And that would be very problematic, right? Because thread exit is the way that, well, you know that the thread has exited. Otherwise, you have a thread that is in limbo state. So, for security reasons, what you want is that you want to make sure that whatever crap the programmer provides you to your thread, it basically finishes and terminates correctly. It does not just litter your system, or it does not do something stupid. Okay, so if you don't call, if you didn't have thread exit, that would mean that you return to whatever random location is stored in the top of the stack, because, well, the thread has finished running and then you need to return somewhere, and thread exit is the wait that which basically tells you where to return. So you basically have this extra level, and after calling function func in the stop, you basically call thread exit, and basically making sure that the thread exits properly. Now, if func has already called thread exit, then you basically will thread exit, and you'll terminate the thread, and then everything is fine, because, well, you're not going to return anywhere. You're going to return with the first thread exit. Okay, so now let's talk about how we delete a thread. A thread basically cannot delete itself when done. I mean, when a thread is done, you should never allow a thread to delete itself, because it's actually, I mean, thread deleting itself is just like a person killing himself in some sense. It can lead to catastrophes. It's much better to basically get killed if you have insurance by someone else than to kill yourself. And it's quite similar in your Linux system. You need something else. You need an extra thread. You need someone to basically make sure that everything is clean, the memory is clean, there are no memory leaks, there are no memory corruptions, and the memory is fully released, and so on. And one of the reasons that you might get memory leaks or memory corruptions is that while the thread is killing itself, if suppose that you come up and say, no, this is inefficient, I want the thread to delete itself. So suppose that a thread is deleting itself and then an interrupt happens right in between. That would basically mean that the thread is neither deleted, But since it has already started the procedure of deleting itself, then it might have already, it becomes in a quasi state, in a limbo land, where it's not fully deleted, but it's not actually also there. And that basically means that there's no way to clean this up. And if you say that, I can do things differently, I can organize deleting a thread differently from what it is currently done and more efficiently, the question will always boil down to this: an interrupt can come at any point, and if an interrupt comes, then you are completely, and that interrupt can have a higher priority than you, because there are things that have higher priority than the thread that is running in user space. And basically the TCB, the thread control block, is the only way the thread and the processor knows where things are. So basically, if a thread wants to, if we go back to this figure, if a thread is done running and it wants to exit, it calls thread exit and goes into a finished state. It does not kill itself. And then once in a finished state, the thread moves the thread control block from the ready list to a list of finished threads. So everything now is on the finished threads. And then you have sort of a garbage collector, if I may say, that basically that is another thread that gets the task of actually moving the data, making sure that data that needs to be stored is stored properly, and so on. And it goes through the finished threads continuously.